Hello, I'm Dave Bonds. I'm one of the system administrators at Diamond Light Source, as you've already heard. I'm here to talk to you about our experiences and our upgrade to Lustre 2.5 recently. It's still very much an ongoing upgrade because it's physically complete, but we haven't finished all of our testing. So for any of you who haven't seen Diamond Light Source, this is it. We're a UK national synchrotron. Specialising in surface materials, so you could consider it as a sort of large microscope. So, whereas CERN is a high-energy accelerator which crashes particles into each other to look at the product of what makes up matter, we are using the electrons to look into matter. This is the accelerating of electrons to produce synchrotron light. And as I've said, it's very much like a super microscope. So just for anyone that hasn't seen what synchrotron is or how they came about, and apologies for anyone that has seen various talks from Diamond previously, sort of early particle accelerators, there was this phenomenon seen that light was produced from the accelerator. This was always seen as a negative thing, and it was only in later on that this synchrotron radiation was deemed to be quite useful. So the 1950s, the starting of seeing this used for experiments. For anyone that hasn't seen, the very first picture of DNA with a synchrotron radiation source and actually what it would look like now with modern techniques. In 1960s, the first synchrotron experiments were being scheduled. Then 1970s, you find that crystallography was a very large usage area of this, and UK saw its first synchrotron built in 1980 at Daresbury. Diamond replaced this in 2008. And we've been going since as the UK's main synchrotron radiation source. So the Diamond machine has got three accelerators. You've got the LINAC, which goes from 0 to 100 mega electron volts, and the booster synchrotron, which takes it to 3 giga electron volts, which is our operating energy. You've got a 562 meter long path that they take. Made up of 48 straight sections. So we've got the bends that are a necessity to be able to use the machine, and on the straight sections we have insertion devices. So, as I said, it's all done with magnets. We use magnets to focus, to guide the electrons, and by byproduct of moving the electron's path, you generate synchrotron radiation. So a good analogy would be if you go round a roundabout increasingly quickly with a car, you get the squeal off your wheels. If you do the same with electrons, you get, instead of squeal from the wheels, you get the synchrotron radiation. So we're not using the electrons, we are using the product of what they produce. The difference being the two types of things that we have at Diamond. A single bending magnet produces a certain spray, whereas an insertion device is long lines of permanent or electromagnets that can produce much more intense beams to look into for tomography, much more intense X-rays. So Diamond, the light that we use is from infrared to X-rays and everything in between. And I hope from this slide, though I don't know the exact details of each one of the areas, I hope to show that at least Diamond is quite a versatile machine, that lots of various experiments can be conducted. It's not just one specialised area. So, though again, this is unceremoniously cribbed from the comms team slide pack. This is very much the types of areas that we're involved in. But going on to more what I want to speak about is the type of Lustre setup we have and how this fits within our network. We are a I think probably one of the smallest Lustre users here, or looking down the list of talkers, I'm very, well, as always, there's a lot of very sort of large names, and well, we don't come anywhere near that scale. But as a small Lustre user, I hope to speak to you about what we do, and if there's any other smaller Lustre users out there, I'd love to actually speak to you. So each one of our beamlines where the experiments take place, we've got a split core network, so we've got redundant paths to the 2 core switches. This is all 10 gig based Ethernet, and this is how it's been since the very early design of Diamond. So we haven't evolved much other than upgrades in this area. So our layout is very much 2 MDSs and 4 OSSs. We're using DDN equipment as the back-end storage. And, well, I said it was small. 470 terabyte of OS2 storage and 1.2 terabytes of MDS storage. And the mix, again, the communication out onto the network is via 10 gig Ethernet, with the back-end storage either being InfiniBand or fiber channel. The upgrade that we've recently done is the upgrade of the code from 1.8 to 2.5, and also the integration of InfiniBand into this. But I will get to those points in a minute. So our first Lustre file systems was 1.6, and more or less we've stayed just upgrading periodically to the latest and greatest. And so we have 2 production file systems at Diamond, one which is based on a DDN 9900, and then an SV10K system. Both of them ultimately get to the same code base. There's a month or so lapse in between, just so we don't break 2 file systems with unexpected consequences of any upgrades. So the latest one, and the version that this talk will talk mainly about, is the second of the 2 file systems, the SV10K based one, which until recently was on Lustre 1.8 and has now been upgraded to Lustre 2.5, and again with the increasing use of IB as opposed to Ethernet for communication. So just to give an idea of what else we have at Diamond, we got XFS file systems for low data rate storage and archiving. NetApp hoovers up pretty much all the other odds and ends as what they do best. GPFS, and of course we have the Lustre file system. So one of the things that we did only have a Lustre file system, and primarily only a Lustre file system quite recently. We have only recently got a GPFS file system, and this was as a necessity because one of our beamlines had the requirement of writing 900 megabytes, single stream, single client, single thread, and we couldn't get Lustre to manage that. So we were getting close, but as this was a hard requirement, we couldn't change it or anything. So we actually found that as Lustre wasn't coping in this area for us anyway, and I'm sure some of you might be looking at the 900 megabytes a second, and actually wondering, sort of, that seems rather low, and sort of maybe that's something that be good to have a conversation about later. And also, going to GPFS, we did notice a number of other issues that when we had our original layout of 1 gig and 10 gig, being 1 gig on cluster nodes and 10 gig being sort of storage servers, we had a lot of performance issues when it came to reading and writing, not to the same file, but even into the same directory or even file system. But mixing the 2 technologies, we found of 1 gig and 10 gig, that we had massive performance penalties, maybe a 40% performance drop in some cases, depending on how bad it got. A lot of investigation did go into this, and sort of DDN were heavily involved in this. and it was never completely satisfactorily resolved, and we always saw this drop every time we introduced 1 gig clients. So part of the suggestion we followed for everyone else, seemingly everyone else in the HPC community was using InfiniBand, and we were told that we were certainly out on our own using Ethernet for for file system communication. So we began to put InfiniBand in, and it did resolve this issue. We're now running with 10 gig in InfiniBand. One thing that was quite good about GPFS at the time was that it has a native CIFS layer, so you could talk to the file system from all our Windows detectors, which initially seemed fantastic, but this ended up being very hard to manage. We had a lot of problems with it dropping out of the cluster, and it was very hard, and we found it always quite hard to encourage it back in. This might be partially our experience at GPFS, because we are very new users, and we are progressing. We did notice that in the 3.5 release that these are being resolved. We haven't had it from DDN yet. But I realise I'm at a Lustre conference, I'm speaking a lot about GPFS. So this is our typical data flow so far, just highlighting how we are moving it. The flow of data to Lustre is via 10 gig in the main. And then we've got the cluster processing, which was always 1 gig Ethernet. And then the local storage servers, or we have this model of a data dispenser, which is a machine Lustre client that sits on the beamlines that a user can put disks or whatever onto to be able to pull their data off as it's being collected. This is changing with 2.5, the things that we hope to gain. We currently have very strict archiving policies. We've got a comparatively small file system for the amount of data that we collect. So we can only really keep data for 6 months. This is something that has always been a challenge, again, for us, that keeping data 6 months, identifying the data, and moving it off in our archiving policy, though we have managed, it's something that we're hoping to improve on with Robinhood and HSUM. And in the future, the whole tiering of the file system, this could be a very nice alternative to some of the archiving where we have to move it off to another storage system, actually have it just move it onto another tier. But that's certainly for the future. We're hoping that Robinhood will help us identify much easier the files that we need to archive. So the other part of this was because our GPFS system, where we were forced into going to InfiniBand, we wanted to have Lustre on InfiniBand because we noticed, well, expectedly we noticed a lot of benefits of InfiniBand. So this was our chance to do code upgrade and put InfiniBand backend in one go. This is our current InfiniBand layout. We've basically gone with Mellanox switches, and in the top of each rack there is a Mellanox switch and straight back to 2 spine switches. So again, it's still fairly simplistic compared to a lot of what I understand is out there in the HPC community. We are, as I said, quite a small user. And now it's looking like this, so you can see that we've added the InfiniBand fabric in, and otherwise it stays the same. We haven't taken out 10 gig, because we've still got some processes that need to use 10 gig. So going through where we've put InfiniBand, it was that chunk in the middle that was 1 gig only. So all our clusters now talk to the Lustre file system through InfiniBand. So to show how we went about some of our testing, this is how we went about using IOR, MD test, IOZone, the standard benchmarks, and a few others. We found a performance increase I'm not saying this is our final graphs, and because, as I said, this is only the initial indication of how it's gone. This was completed basically last week of the code upgrade, sort of definitely spurred on by having to come here and talk about it. So there was a performance increase. Fantastic. This is what we're aiming for. We're aiming for features and the performance increase. We're yet to quantify all the areas that this performance increase actually has benefited us. But just on metadata performance, we can see that we've managed. The next graph shows that our initial benchmarking hasn't actually saturated it. This is something that we're going to go and re-benchmark, that we've found the bottleneck somewhere else. But this is part of our ongoing looking into, well, now we've got this, where has our bottleneck moved to? MD test for slightly horrible graph, but each pair you can see that has had a increase all along, so practically, basically across the board for the MD test operations, we've seen in some cases very large improvements. So as I said, we are still, the first users are using it today. So we'll see very soon how our real-world testing is going to go, and there's certainly a tradition at Diamond for every presentation has to have an XKCD cartoon, so enjoy. So the future at Diamond, we've got a new facility being built currently, which is going to be another beamline and also hold 4 electron microscopes and will be the National Electron Microscopy Facility. This is very much triggered our looking into of the next generation of file system at Diamond, whether this is Lustre, GPFS, something else. So this is very much that we've got a number of detectors already. Sort of first two, the PCO 4000 Platus, are capable of 640 megabytes a second, and currently the existing technologies that we have and quantity of these detectors that we have, our file system is coping. But in the future, like with the Percival detector, 5 to 6 gigabytes a second, and certainly there is sort of the ability for sort of 10 gig line rate detectors, though these are a little way off yet, but still something that we need to look into for our next generation file system. The electron microscopes for us, because Diamond has never had one, is a little bit of an unknown, and all the various people in Oxford that we've spoken to, sort of, it's a lot of data. Like it would be 6 10 gig streams, but it gets decimated down to about possibly 1 10 gig stream. This is a little bit of an unknown, though this is what we're keeping in mind for our next generation file system. We was very much like it to be Lustre, but sort of some of the requirements that we've got is that single client performance, and it was really encouraging to hear that for the next version of Lustre may go some way to resolve this. I'll be very interested to test this. So as detectors are trying to write into the same file, this certainly has always been a bit of a limiting factor for us. And to do it quickly, we'd like to be able to saturate a 10 gig stream, or even better, is saturate InfiniBand, though that's maybe a slightly taller order for sort of the type of file system and what we're doing with it. But and it'd be nice to have a native Lustre client for Windows. Sort of, there was talk last year on sort of that development, and though it's certainly not one of our hard requirements, sort of it would make a world of difference for what we're doing to have a native Lustre client for Windows. So, any questions?
So you mentioned that one of the reasons you went with GPFS was because of the single stream performance.
Yes.
But then you upgraded to InfiniBand. Have you tried the single stream performance with Lustre on InfiniBand?
We did. There was, as part of the testing, because we didn't really want to invest in GPFS, so we actually did do a lot of testing with Lustre, and we did have a very small InfiniBand setup just to actually see if that was our bottleneck. That didn't, it certainly was improvement, but didn't get to that magic figure that we were aiming for. So no, we did test, but it didn't get there.
Okay, because yeah, I mean, there is ongoing, maybe probably not in the version that you have, but there's ongoing, you know, development in terms of Lustre single client performance. So hopefully for your next system, you can get the numbers you need.
Yes, because GPFS is phenomenally expensive.
So how smooth is your 1.8 to 2.5 software upgrade? Did you just install the RPMs and it works, or did you have to fiddle?
What was this? Is this an incredibly, talking to you on the coach, I understand that yours was far from smooth. But yes, with very little effort, we installed the RPMs and it worked. We had one issue and we had a patch for it, but apart from that, we haven't seen any lasting issues. And I hope we won't, because okay, it's getting properly field tested today. But sort of all the indications we've had so far, sort of it hasn't had any detrimental problems. Well, thank you very much.